Hello and welcome to the DSM Network. We have launched a new initiative to engage our wider audiences by means of a video series. In today's inaugural video, we will discuss an interesting article published in the journal Materials Today Chemistry. The title of the article is Resilient and Agile Engineering Solutions to Address Societal Challenges such as Coronavirus Pandemic. Dr. Tanja Radu from Loughborough University will lead the discussion with two of our network members who are also co-authors, Dr. Saurav Goel from London South Bank University and Professor Vijay Thakur from SRUC. So without much ado, I hand over to Tanja. Thank you.
Thank you very much, Pamela, for your kind introduction and for invitation to host this event. As COVID is now becoming part of our lives, it is interesting to discuss the latest development in research with experts in field, Saurav and Vijay, especially following their latest publication. The paper has been published 2 months ago, and in this discussion, we'll be exploring the latest developments in field. So to begin our discussion, Saurav, which of the technologies initially described in your papers are showing promising results against COVID and some indication that they could be part of the solution?
So thank you, Pamela, and thank you, Tanja, for that very nice introduction and the question raised. It is, first of all, the grand pleasure for the DSM network to undertake this initiative for discussing the implications that COVID has been portraying onto the various engineering fields and related implications also on the wider other fields. So to answer to the question, as you already well know, that there has not been any particular method or medication that has been particularly been successful against COVID. Vaccination is the most sought after goal. However, from what is apparently promising at the moment seems to be something sort of a technology called blood plasma, whereby the fresh COVID recovered patients can donate their blood, and then that blood can help cure the infected patients. So to give you an example, a country like India, which is on the verge of becoming the most infected COVID nation, have recently inaugurated country's first blood plasma bank in the capital, New Delhi, and it has been kind of projected to be very nice treatment procedure for fighting COVID. Although in the long term, vaccination remains to be the most promising method to cure COVID. Thanks.
Yes, to add Saurav's discussion on this one, UK government is also now exploring the use of plasma, how we can use this technology to change the life of people, because with vaccine, we are still uncertain, although lots of news are coming from Oxford or Russia, US, India, but no one is certain about their efficacy. So it's very pertinent.
Thank you. That's great. And that brings me to a follow-on question regarding this. So the MIT has recently predicted that India will be the worst hit nation from COVID, and you seem to agree with this. In response to this, as you mentioned, Indian government has already commissioned hospital for donation of blood plasma. However, the Western countries are mostly focusing on the development of the vaccine. So could you please comment on these different approaches between Western countries and India?
Wow, that's a very thoughtful question. So I think to begin to answer this question, one has to look into the evolution of how COVID actually came into light. I think you would agree that India was among the earliest entrant in pulling together the lockdown procedures, while UK was amongst the latest entrant into this, because they were actually going initially with the herd immunity concept. And as a result of that, most of the Western countries, including the UK, for instance, they had this first peak, which is clearly visible in the number of patients infected. Whereas India, although were early entrants into the lockdown, but what happened as a result of that was that while the COVID patients still continue to grow, India had no choice left other than to unlock its lockdown. And in that process, while the unlock procedure it started to begin, the COVID cases still continue to grow. So the India never theoretically saw any peak or experienced that peak. Now, what is happening here is the population burden is immensely high. So vaccine is, although the best bet on which the country can rely, but considering that the cases are continuously growing, they had to find an alternative solution other than waiting for the vaccine. And blood plasma seems to be one of the nicest procedure at the moment, beside the medication that the doctors are continuously trying their best. So it was not that the approaches followed in West and in India, for example, a country like India, were different, but India was left with no choice other than just to look after the secondary treatment procedures, because otherwise the country's medical facilities and the burdens of the doctor would be too much humongously high, so that they cannot cope a kind of havoc situation. So in order to come up with the nicest solution that could have been possibly made, then India decided to also take secondary approaches rather than waiting for the vaccine to come in. That's what the situation is like, I think.
Thank you. To continue, your paper has been published 2 months ago, and would you please discuss what are the lessons learned since that time? Would you say that your opinions expressed in the paper have since shifted or changed in the light of the latest information in field?
I think the paper covered almost every latest advances that we have been witnessing in this field, including from the biological origins to cover how basically coronavirus started to emerge, the situation, how it started to emerge, and how the world responded to it, country by country, different procedures, different kind of routine lockdowns and phased lockdowns and so on. I think the situation is continuously evolving still, and the world is still not fully recovered because the shock of the pandemic was such that many people end up losing their jobs, for instance, which was not a very nice situation. In terms of the solutions, I think many proposals were made in the paper, which seems to be currently adaptable to a large extent. So, for example, the foremost of this is wearing of masks. So even every government is now recommending, and some of them making even the rules that this will otherwise be penalized. Social distancing concept remains to be vital and pivotal against this fight in coronavirus situation. And I think from DSM perspective and also from our perspective, we felt that introducing antiviral coatings on textile polymers and biosafe surfaces in long terms, especially in hotspot domains such as hospitals, transportations, railways, aircraft industries, and so on, would be favorable, I think, in the long term, not only just to cure coronavirus, but many other similar virus situations, including MERS and SARS CoV-1 and so on. So there are these long-term solutions being explored now within the DSM network and by many other institutes around the world, and we look forward to find out the long-term sustainable solution on how to scale up these implementations and come up with the nicest solution for the humanity.
Also, Tanya, in our paper, we have focused on manufacturing aspect. And if you see now, most of the countries, they are focusing on indigenous manufacturing. So in that sense, after publication of our paper, most of the countries are putting great emphasis on how they can use locally available resources and innovative manufacturing technology to get prepared for, how you say, such type of events in the future. You really don't want them, but you should be prepared for them. So that is one another intake from the paper.
I see. Thank you. So in the last several months, we are witnessing that the virus is not exactly behaving according to expectations, and its exposure to sun in summer months is not actually resulting in the expected lower activity. Quite contrary, many countries worldwide are now experiencing surge in new cases. It shows that measures such as social distancing and wearing masks are the better form of protection. Would you please discuss or comment on this?
Oh, it's a very good question. Actually, it reminds me of the discussion that I'm having with one of our colleagues who is co-author on the paper, Dr. Oliver Pierce, who is a medical professional. And I had exactly the same question asked to him. In fact, I would have went on to even discussed this in the paper, then he immediately reminded me that sort of there's a basic difference between what's called as in vitro and in vivo testing. So this might be true. Like there are some reports coming out, including President Donald Trump from the US, alluded to the fact that as the summertime is approaching, then the virus will basically disappear. But the fact is that quite possibly, it's not sure yet. Maybe the in vitro exposure of sunlight, which means outside of our body conditions, might be able to denature the virus, although it is not established yet. But what is not sure that what aspect of sunlight actually kills it or basically denatures it, whether it is the ultraviolet exposure, whether it is high temperature caused by the sun cosmic rays or something like that. If that is to be established, then one would imagine that we have shown in the paper that the lab testing through burette, what you call it as basic chemistry titration experiments have shown the virus is very highly stable until 60 degree. In fact, it is also stable between the pH value of -4 to +10. So it means it can go from very basic to acidic conditions. And there's a reason why it is called as novel coronavirus. It is not an ordinary virus which can just simply be denatured. So it has to be assumed that if temperature is not that factor that can denature the virus, it must have to be, it has to do something with the ultraviolet radiations. Now, this is an aspect which is worthy of looking at, because some countries, including India, for example, have started looking into the possibility of introducing UV fumigation chambers, which is how they are planning to cure coronavirus. But further research is needed on this, and it is not very sure that this is the case. And I think that's what basically pulls down to this question that if UV is responsible and not the temperature to denature the virus under in vitro condition, then the best way to look at the situation would have been would the kind of regions within a country or across the continent or across the world or the globe receiving higher extent of UV radiations would show a better decline in the cases of COVID. And that is something that one need to look at, and yet there is no research done as of now on this subject, but it will be something that would be a very nice thing to look at. Until that is done, I think the best way to save yourself would be social distancing following.
Thank you. So to continue from the previous question, and in addition to UV related research, could digitalized processed coatings aid in production of better, more efficient masks for multiple use? And would you comment on what other currently used PPE could be improved by introduction of such services?
I mean, it's a very tricky question, and it will be unfair to say that it will do for sure, because there is no research done on this aspect yet. It's just still a hypothesis and sort of a postulation made by the scientists that such a kind of discovery would at least result in containment of the virus. But what we can definitely say from the understanding and established knowledge in manufacturing aspect is that digital processes to produce a certain product, including the coatings, or for PE, personal protective equipment like PPEs, will provide better control on the efficiency and the repeatability and sensitivity of the performance. So you can expect more compliance with the theoretical coating standards that you will, the quality standard that you will set. So there is a thing called design, and there is a thing called manufacturing, and the differences between the expectations and what you actually get from the experiments is what leads to a sort of defect in production. And these sort of defects are almost inevitable. So having digital manufacturing adopted and embraced into a manufacturing system leads to better monitoring of the system and processes, and thereby reduced number of defects in the production. So by adopting such an approach, I think what one would expect is that you can get, or you can actually claim to make a percentage number, specific percentage number, that this particular surface or this particular coating is going to be antibacterial or antiviral to give you this much percentage efficiency. Now, on the same topic at the moment, many companies do not even recognize the simple difference between antibacterial surfaces and antiviral surfaces. And this is something we tried to discuss in our article as well. Whether it is coating or whether it is some product, some companies are boldly just claiming that, you know, these are antiviral surfaces, they will take the COVID off and things like that. The reality of it is they didn't even themselves tested it for stability against COVID. So I think I can just boldly say I don't remember any particular commercial surface as yet being tested against COVID. It means that whatever surfaces are being fabricated in future or in present times, they need to be specifically testing against COVID, and they would then be categorized as COVID resistant surfaces. Even if you claim something to be antiviral, it is not sure that it will definitely be bacterial or viral resistance in nature for every particular species that we know to be a virus or a bacteria. So these are some of the minute aspects that biological people would understand that definitely, but common person, common public to whom consumer goods are sold would not know these aspects. So digitalized manufacturing processes can help to put together these quality standards in place that will help consumers to know such kind of implications.
Thank you for your very detailed answers to this question.
Thank
so to continue, Vijay, would you please then comment on the cultural implications in various approaches adopted for fighting the virus in Western countries and in India? And how does local Indian advice differ from the global WHO advice? What is the role played by the historic traditions and approaches when it comes to medicine?
Tanya, it's very interesting question and tricky one. So the cultural implications have been significantly different in India and the Western world. The Indian system is very different, or you can say unique, in the sense that social distancing lies in its DNA. When you meet someone in India, you generally don't shake hands. You simply say namaste. So it is a way of saying your greetings to everyone. So you mean you are not physically touching anyone. And this is really very important in COVID-19 scenario, where we have most of the chances of spreading of this very, how you say, dangerous disease by contamination. And then one another traditional practice has been, if we go back our, okay, say 40 years, 50 years back, old people, they used to drink water from some special pots, or how you say, cups. They were mainly made up of brass, which is nothing but a mixture of copper and zinc. And if we see lots of news today, most of the antibacterial or antimicrobial coatings or claims Saurav was talking about as well, they are making use of these materials to so that they have very good properties. And these pots have been used for drinking water. And what old people in the morning they used to do, in the night they will put water in this pot, and early morning they drink it. So it has been more of a healthful practices, but generation like us, they are forgetting it. So I think it's time to look back into old tradition as well, so that we can be prepared for future pandemic. Although they are very unfortunate events, but we must face them, right? So in that sense, its culture have been significantly different, and even from food habits, if we see from some of the recent literature that shows that turmeric or another natural, how you say, antimicrobial material or natural supplements, they have the proper, how you say, advantages to combat with these viruses. So if I talk particularly about turmeric, it is used almost in every Asian, leave aside India, food. So it is a very good material or substance to increase your immunity. So there are some slight difference. So I think combination of both the Western and Indian world will make a very potent solution along with the vaccine to tackle this at different levels.
That's very
So
interesting.
just to add to that, Tanya, I mean,
Yes.
if you go by the some sort of mythology of how Indian people or Indian origin culturally used to start to their day forward was that you would either potentially use a silver utensil or you will either potentially use a copper utensil, which appears to be like a modern day jug, but not made out of porcelain, which is most popular crockery used these days. And all the mythologies and all the great grandfathers and every grandmother would tell their children and things like that, that if you keep the water overnight into this kind of metallic beaker, not steel, only either copper or silver, and you should consume and make it a habit to drink this water early morning daily. I'm not sure. I have heard, like, for example, from my grandmother that it will be definitely antibacterial or antiviral or anything like that. But I think they used to tell me that at least it helps you get rid of your toxins in your system, digestive systems to get rid of, so that your digestive systems remains very clear throughout the day. So that's why you do it early in the day when you wake up. And I think just like Vijay mentioned, what we are witnessing now is the adoption of Indian Namaste, which is a standard greeting in India, being adopted by Donald Trump and even French president while the pandemic kicked off. Very soon, no doubt, we will be actually using acceleratedly these kind of materials, which are well known from the ancient times to somehow fight resistant or be resistive against bacteria and viruses.
Yeah, even Prince Charles has been practicing this with the people he has been meeting. So from the early breakage of this pandemic.
Yeah,
I think we must adopt each culture's best habits and best supplements.
Yes, and that also gives us ideas for future research, I guess, in that area. Yeah. Okay, so Vijay, India is now the second largest manufacturer of PPE. While this can boost the local economy, it also creates problems with excessive use of plastics and its environmental implications. We are now facing the challenge on how to replace plastics by more environment-friendly alternative materials. So could you please give your view on this issue?
Yes, this is very pertinent, and I think one of the most important questions that has arisen during this pandemic. I'm sure you might be aware that today our oceans have more plastic than the fishes, and this pandemic regime since last 3 months has added it to several folds. And if we talk about the composition of the surgical mask or respirator, they are made up of layers of plastics, and they are mainly designed for single use. So there has been some reports that says, if we talk about from UK perspective, that every person in the UK for whole year, if every day he or she uses one mask every day, so there will be more than 66,000 tons of contaminated plastic waste. And we don't know how to recycle it, because if we talk about in reality, there are very less amount of plastic that are recycled. So a pertinent solution for this is we must shift our research efforts to make use of sustainable resources to prepare alternative eco-friendly materials. And you are well aware of this, as you are also working in the area of sustainable material. So there is no dearth of these materials in our nature. If we talk about cellulose, which is the most abundant natural material on the earth, it can be used for a number of applications, provided it has been suitably processed and surface engineered. And if I talk about SRUC, we are now focusing more efforts on use of agriculture-based materials for value-added applications. So I can see that natural-based materials are the only choice we have to address this plastic issue.
which includes bioplastic, for instance.
Yes.
Okay. Yes, another interesting topic for future research, I guess. So to move on to the issue of monitoring then. So following publication of your article, the focus is on the early detection of virus, but monitoring remains an issue still. Can current technologies offer new solutions in this field?
Yes, monitoring is a critical issue, and current technology right now we are using in the same way they can offer solution, especially digital medicine technologies. It is digital medicine which integrates technology together with human intervention, as well as how you can say we can communicate with medical specialists to get opinion about this. Like if you remember in UK when this outbreak started, we were just consulting our GP through phone or Skype call, right? So in that sense, I have come through some news that in India, especially it was well before this outbreak, that governments were pushing on how they can use this digital medicine technology to help people. If I talk about my state, it is more of Himalayas. So there, even if you have to travel 50 miles, you need to drive 4 hours or 5 hours. So you can see, so government has started this program where you can have an appointment with a doctor, and through these virtual resources, say Skype or another online resources, you can directly talk to the doctor. You can discuss with him what are the problems you are facing, and if it is not serious, or you can say some tests can be carried out locally, then you can avoid this traveling, and you can have better guidance from some of the best doctors sitting in big cities, or you can say capitals of different states. So that is one very important point you have raised, and I think each country should focus more on it, how we can use this digital technology or modern techniques to empower everyone.
So one thing to consolidate there, Tanya, is one of the biggest challenge from medical science has been to detect asymptotic symptoms. You can actually potentially use MRI and RT-PCR, these kind of techniques. But by then, COVID has already invaded your system. And so it's kind of a late. The question that has really remained at the center right now in terms of scientific research is how do you detect early symptoms? And for that, there are some more research is needed. Advanced sensing needs to come in place. Nanoparticles-based solutions can be also discovered. There's a lot of room for research in that area yet, because as of now, only lab on chips, RT-PCR and MRI, these are the kind of established standards tests, which are done at a later stage of the infection. But if we can do something at the early stages of infection, we can even then control that necessity of quarantine, which will not be required if you detect it in early stages. So there is scope there.
Yes, very, how you say, very important information. And to complement this, artificial intelligence is currently being used by using data from different patients and then combining it with laser technology, how it can be detected at early stage. So we used to have a collaborator, Dr. Pramod, who has recently moved to UAE, and they have developed this technology of laser assisted by artificial intelligence, where they can screen any number of patients within few minutes. So I think it needs further research and more deep research, as Saurav suggested. Like if we can tackle this at the initial stage, then we are done.
Thank you both for your very detailed answers. So to move on from monitoring again back to the issue of solutions, potential solutions, there has been significant research and effort going towards development of the vaccine. But are there any other potential approaches? For example, in light of your own research, the use of antiviral surfaces, textiles, or materials?
Yeah,
Vijay would love to answer this.
Please.
To be honest, there is no alternative to vaccine. What other approaches make sense to slow down the effect of COVID-19? So we must look into another approaches that have potential to slow down or even stop the spreading of this virus. So if you go through a lot of news, or if you even literature that suggests that this virus has spread through hospital as well as one-to-one contact or coming in contact with different surfaces. So it has become very permanent. We develop new, how you can say, smart surfaces, or you say robust surfaces that have these antiviral or antimicrobial, whatever you want to say, type of characteristic embedded within them. So if our surface is, say, starting from our door or houses or windows or any office or whatever surface we are coming in contact, if we can really make them antimicrobial, I think that is going to help a lot. So in that sense, making these surfaces super smart with self-healing and self-cleaning will take further, but it need deep research that can help us make a small contribution to this direction.
So one thing on that point actually is, Tanya, that we have actually provided a comprehensive chart in our article to just simply show that because this virus is more like a carrier of the disease, coronavirus disease. So this virus can actually remain alive for different duration of time, depending on the surface on which it sits. So for instance, if it need to sit on a copper surface, it lasts for about 4 hours, as to a steel surface where it can actually last for about 7 days. So you can imagine that you are in a hospital environment or a kind of environment which is dominated by public movement. It could definitely be airport zone, transportation zone like a railway station and so on. And accidentally, if there has been a COVID patient going from nearby, so the airborne COVID droplets can actually deactivate by themselves, let's say after 8 hours or something. But if the virus get a chance to sit on a metal surface, whereby research has been done to find out how long can it actually survive, it can remain active for up to 7 days. What it means is within that duration of time of 7 days, if somebody accidentally come in the nearby vicinity of that area, would have greater degree of chances to inhale the virus. So to potentially avoid such an episode, biosurfaces, or what we are calling as antiviral surfaces, would potentially try to denature the virus immediately or within like 5-10 minutes of the contact time. That means the likelihood of getting further accelerated infection would reduce significantly. That is the implication that we are trying to allude to here in relation to the biosafe surfaces.
But that then brings us to a follow-on question. If the knowledge of antiviral and antimicrobial surfaces is already well known and developed, why is it that biosurface community can come forward in this situation, offering solutions and materials which will prevent the virus spreading?
Yes, it is very relevant question and I think tricky one. Traditionally, these have been two different communities who have been looking from different perspective. If we talk about virologist or microbiologist, they have been looking into different antiviral or antimicrobial surfaces for implant applications, not for typical surfaces. While engineering community, they look it from different large scale manufacturing. And if you see, there is significant difference in properties when you compare their, how you say, areas. So now we are joining hand together with researchers from different expertise to come together with a unique solution that combine expertise from engineer to material scientist to chemist to virologist to come up with new materials and surfaces that can address this problem.
So to further elaborate, Tanya, on that, this is something from my personal experience that I'm understanding. Although I'm not a biologist, but I'll share what I understand about this topic, which is actually becoming an implication at the moment and has become an impediment to this research. That obviously, as you know, COVID, when lockdown happened, everything was shut down. There was no provision of entering any lab, let alone just to do research about this topic. And usually what happens, one has to carefully understand that when we say antibacterial or antiviral, it does mean that not all antibacterial materials or antiviral materials are resistant to every class of virus or every class of bacteria. In particular, for COVID, I haven't come across any single article that has claimed that this particular surface has been resistant to COVID. Like there are a number of viruses like this. For example, chikungunya is one famous virus in India, and dengue is another virus, which is mosquito-borne virus. And just like a vaccine takes time to develop, the surfaces that could be potentially resistant to a specific virus takes a long cycle of development. There are recipes involved from chemistry side, which Vijay is very much rigorously working on, about looking at cation and ionic kind of interactions, on how the receptor binding domain attaches to a surface and so on. And then the biggest challenge is how to develop them at a large scale. Large scale manufacturing of these kind of surfaces require precision. And this is something that nobody has ever done in the world. And then if you want to test something like COVID to declare that this is bacterial resistance or virus resistant surface, whatever, against COVID resistance, for example, this required you to have access to level 3 biolab. Now, this is something not even the top economies easily can have. So for example, even if I am a research scientist and I want to test something that I feel that it is COVID resistant surface, I could not easily find such a lab just to get access to get the COVID access testing. And even if I need to find out really the person who would be very easy to volunteer himself to do such kind of testing, because the first thing you get is the sense of fear. Oh, what if I do this test and I got infected by COVID? So there are a lot of such kind of implications that are required to be undertaken. And this is a truly interdisciplinary kind of research area. It involves material scientists, as Vijay said, chemistry, virologist, bacterial side, large scale manufacturing, and all of that requires research through a comprehensive manufacturing program, I would say, which we are looking forward to.
Thank you. So I guess that outlines the research challenges that we still have in the area and the challenge of availability of research facilities. So in light of your own research, would you both please give us a little bit more information about your current research? So are you continuing to work in this area? And if yes, what sort of scientific goals are you pursuing at the moment, and what methodologies are you adopting in your future research?
So if I talk about myself, I am working in this area since last few years. We have been looking into development of different metals and metal oxide based nanomaterial with particular focus on zinc and silver oxide based nanomaterial for antimicrobial applications, as well as coating for implants. Now at SRUC, which is a premier agriculture and veterinary institute in the UK. And as Saurav said, there is always very difficult to how to find these level 3 facilities. We luckily have these facilities and access at SRUC. And now we will be looking mainly into the development of new natural antimicrobial material along with these metal oxide based nanomaterial, and how we can embed them in different systems using advanced engineering techniques. This is where Saurav and another engineering colleagues' expertise comes in. So we are also interested in looking into how COVID-19 has impacted the agriculture sector and whether the disease can be transmitted through animals. So I can see my research becoming now truly multidisciplinary and interdisciplinary, collaborating with a lot of engineering, virologists, and medical colleagues. So most of the research efforts will be focused on sustainability and biomedical research in next 10 years, I can say.
So from my perspective, Tanya, since this pandemic actually occurred, I got trapped in India because I came on a business trip just before the lockdown was implemented. And actually it was during this time this article was produced, by the way. So it was the sheer drive that allowed me to think, we have to think of the situation. So for a couple of last years, I've been similar to Vijay, taking engineering approaches in understanding of the viruses in general, not particularly COVID. So for example, one of my PhD student at Cranfield University, Sarah Harvey, is looking into antibacterial surfaces creation through laser-based micromachining for implant applications. And this is how I first of all started to get in touch with the medical science professional like Dr. Oliver Pierce, who is one of the co-authors, which has then led us to go into this direction of COVID article that I think we should have written what we did. And now I've just recruited a new PhD student at London South Bank University, Mr. Saeed Hussain, who is going to look into the use of computational models, fluid dynamics based models, to discover the airborne spread nature of this coronavirus. So one of the questions that have not been answered as yet is how does the humidity around the atmosphere, how does the air conditioning around the offices, how does the presence of other colleagues near you, even despite of social distancing, but because their respiratory system remains active, can influence the spread of such kind of pathogens. And to address this, we have requested London South Bank University to boost us with the required manpower. So they have courteously offered me a PhD studentship. So I've just recruited the student who is going to make use of computational fluid dynamics model to elucidate the airborne spread nature of such pathogens through computational modeling approaches. And besides that, there is a Royal Society Newton Fellow that I'm having, Dr. Nirmal Kumar, who is also looking into use of thermal spray manufacturing processes, which is also based at London South Bank University, to create such surfaces that we have been talking about. And actually, in fact, this was the spirit with which me and Vijay started to think about these. And now we are consolidating a research program, comprehensive research program, to bring together a team of or a consortium of people offering their own skill sets from engineering, large scale manufacturing, biology, and trust areas that will then allow us to do a comprehensive testing and creation of these biosafe surfaces, which potentially would not only be very much effective against COVID-like virus, but also many other viruses that will have implications in the future.
Okay, so potentially groundbreaking research coming our way. Thank you both. To conclude this discussion, one last question from me. Would you please, both of you, would you discuss what was the impact of COVID on your own research and work life? And also, how have you been affected personally by this pandemic?
So yeah, it's for me. It has been how to say. There are no words to describe it, but it has been very strange and unique. I was to start my new job as a professor in SRUC, and as you expect, generally you are expected to join in person, but because of this outbreak, I have to start it virtually. And over the last 3 months, I was based in Cranfield, working for SRUC. So it has been a very unique and different experience using digital technologies to work in a new place. And then till so far, I have not been able to access my lab here at SRUC because our labs are still in lockdown mode, and now we are developing the necessary procedure how we can open. Some of the labs have been already opened, but especially for me being the new appointee, so we are just trying to sort out some new things. And then personally, very disappointed. I was about to travel to India for my daughter's very first birthday. That was on 8th April, and it had to be in quarantine, and that too virtually. So even at my home, my parents and my wife, they celebrated it. So it has been a very different, sometime, I don't know. You don't have words to express it, but it has not been very pleasant, except that you learn to use these new technologies to get adopted to the new world.
Yeah.
Yeah, for me, as I said in my previous answer, that I came on a business trip precisely on 6th March to actually join and give a talk at Indian Institute of Technology, Roorkee. And immediately, just when I was about to return, the day before that, lockdown was implemented. So I remained stranded in India since then, which would have been not a problem. The problem is the place that I'm staying nearby to that institute where I visited is having no internet service provider. So I am very difficultly managing even my day-to-day operations in the absence of a good internet facility. And I think in this time, what I specifically realized is that if you were to adapt digital technologies, you have to have this sound electronic infrastructure. So now people have been talking about even 5G and Huawei's ban and things like that have been discussed. But I think government needs to find a particular solution, which is what I felt and I realized, and I even tweeted about it to the state government in here in India to say, look, please provide the healthy infrastructure of the internet so that I can at least deliver my teaching slots. So there were some teaching sessions that I had to deliver while I was on the business trip. And I struggled greatly with that. And obviously, I should say, I almost forgot to see the sun because the lockdown and the growing number of cases were so fearful that you will barely actually dare to go outside of your house in the hope that you do not want to infect and die alone, kind of in another third place sort of thing. So those were the implications. But other than that, I think everybody was remotely locked and everybody had to take the pain of this situation. And I am sure you must also be one of the, some are indirectly or directly, but somehow now the situation is getting normalized. And because the flights remain completely locked, no travel was allowed. It is expected now from August somewhere, India will begin its international flight operations, and then I will hopefully come back to the UK to resume my normal routine operations. So the surprise element was that it was Vijay who was supposed to be in India, not me, but it happened to be opposite experience of that sort.
I left India after finishing a arrange project on 2nd March. So
That was lucky escape.
Yes, yeah, you can say like that.
Okay, so yes, thank you very much for sharing that. And this question concludes today's session. So I would like to thank you both for this discussion. It was my great pleasure to have this conversation with you. I wish you both the best of luck in your future research. And also I hope that you will keep updating us on your research results and that you will keep producing high impact scientific papers contributing to solution to COVID situation and the pandemic. So yes, the best of luck and thank you very much.
Okay, thank
so
you,
much,
Tanya, and thank you, Pumila, for organizing this session. And
Yeah,
Saurav
and
for
thanks greatly to the DSM network also that has resulted in this webinar. And I'm thankful to somehow this current internet facility that has worked uninterruptedly for this particular session somehow.
yes.
We can't hear you, Pamela. You are muted.
So thank you so much for coming together for such a interesting and stimulating session. And I'm sure our audiences will find it very informative too. And also, maybe, I think this might give an extra perspective, a new perspective for traditionally very different sectors to come together and work more cohesively to tackle global challenges like coronavirus pandemic. And it would probably, steer our research towards, most robust and innovative and interdisciplinary scientific research. So thank you very much all. That was great to hear from you. Thank you.
Okay, thank you, Pumila.
Yeah.
Cheers.
Thank you, Tanya.
Thank you,
Bye.
Tanya.
Bye.
Good luck to your research also, Tanya.